The first one is how did the universe begin? Like, what started it? You have nothing, and then you have something. Like King Lear said, nothing comes from nothing. So how do you? Let's start with how do you get from nothing to something?
We have no idea. So, next question.
Yeah. Oh,
We got top people working on that one. Okay?
and they all have pets, butt naked pets.
Actually, it's not that we have no idea. We have some rather interesting ideas, and they're all traceable to the concept of the multiverse, where we, in our friendly universe with known laws of physics, are just one bubble of many bubbles that would come in and out of existence in this sort of meta system of multiverses. And if that's the case, then we can definitely point to a beginning of our universe because there's some other structure that's there pumping them out and pulling them back. But that just simply shifts the question to how did the multiverse get here?
Yeah,
and we
that
have
doesn't
no
seem
clue.
like that's sort of a turtles all the way down kind
Yeah,
of.
in principle it could be, unless the multiverse was always there. And I know that's philosophically unpleasant, but if you're exploring open-minded to what is possible in the universe, quantum mechanics looked really weird to us in the 1900s, in the early 1900s. Just because it looks weird doesn't mean it can't be true.
So does that mean that what we think of as nothing is actually more than nothing? So
Yeah, there are levels of nothing. For example, if you go out into space, where there's no air, you'd call that nothing. But now sort of leave the universe where there's not even space. That would not even be nothing. If space is nothing, and then you don't have space, what else are you going to say? It's not even nothing. Or rather, we have yet to come up with a word for it because we don't understand enough about it to name it.
what about the idea somehow that something pops into existence? Okay, so we'll call it
Wait, by the
matter.
way, he's going to ask me all these questions about which we have no answer. Yes, that's part of the book, but there's a lot of other kind of known stuff in the book too.
Yeah,
right?
yeah.
You don't have to just be depressed that we don't know what's going on. Just want to clarify that.
This is a subset of that question. We'll skip over the part we don't know, and we now look at the stuff that pops up. So it's something called matter, but you do describe that for everything that we observe, every proton, every neutron, every electron, there seems to be a equal and opposite thing carrying an opposite charge. So for the sake of vanity, I guess we call it antimatter. But the question, and when they meet, they essentially annihilate each other.
They're not even essentially. It's just annihilate.
So how
No
come-
modifier necessary. Yeah.
but still we're here. So if every electron in you, every neutron in you, and every proton in you has an equal and opposite and antagonistic opposite, why aren't you popped out of existence before you even start?
Because in fact, not all matter particles have opposites in this universe.
And isn't that a mystery?
Yes, it is. One of the most interesting mysteries of the early universe. And if I may give some background on that.
Sure.
14 billion years ago, or if you want to be 3 decimals precise, 13.7 billion years ago, the universe was much smaller, much denser, much hotter. So hot that matter and energy formed this soup of interplay. Right now, you take it for granted that we sit here and you're not going to pop into a ball of energy and dissipate into space. We kind of expect that is not going to happen quite that way to you. And so why? Because we don't live in an environment for which that's an everyday occurrence. But there are environments in the universe where that happens all the time. Like, for example, the center of a star, at the origins of the universe. In fact, if we were immersed in those environments and did not otherwise vaporize, it would be a very natural thing to watch particles pop into existence out of nothing, but it's actually energy, and watch particles come back together and make energy again. That's a very natural thing, exotic to us, requiring an Einstein to have figured out. But under some conditions, it's just every day. So you go back in time, and you say, here is this ball of energy. And as the universe cools, the energy spontaneously becomes matter. Now, if you're hot enough, that is a two-way street. Matter becomes energy, energy becomes matter. But as the universe expands and cools, you reach a point where the pool of energy is no longer high enough to make particles. Okay. Well, if that's the case, all matter and antimatter would come back together, annihilate, make a beam of light, and all we have in the entire universe are beams of light. But that's not the universe we live in. The universe we live in has an imbalance of matter and antimatter. In fact, for every 100 million matter-antimatter particle pairs, there was one surplus matter particle without a counterpart. And it's a big, mysterious asymmetry. We don't know what caused that asymmetry. We have some ideas, but we don't know for sure. But there's an asymmetry, and all stars, galaxies, planets, gas clouds, light, everything you've ever thought of as a thing is made out of that 1 in 100 million particles that did not annihilate. And everything else is just light. And that light we see, in part, as the cosmic microwave background in the universe.
You know, it's like a whew. You know, we got lucky. Or
there's 100 million other universes where different laws of physics unfold, and we could only be having this conversation in the universe for which that's true, which then doesn't make us lucky. It just makes it sort of the reality of the moment. I'll give you an example.
Okay.
I'll give you an example. Try this experiment. And I encourage you, yes, do this at home. Yeah? Okay. Take a coin. Actually, this would be really hard to do at home, but it's not dangerous. Get 1,000 people, line them up. Then get 1,000 coins, identical coins. Hand them the coins. Have them flip. Whoever gets tails, have them sit down. That'd be about half, if it's a fair coin. So 500 people sit. The rest do it. Flip. 250 people sit down. The rest flip. 120 sit down. The rest flip. 60 sit down. Boom. 30 sit down. 15 sit down. 8 sit down. 4 sit down. 2 sit down. We got 2 people left. They flip the coin. One gets the tails, one gets the head. One person is left after all of that. Okay? And they win a prize or something. And they ask that person, what do they have to do to win that contest? They have to flip a coin, heads, 10 consecutive times. And almost every time you do that experiment, somebody's going to flip a coin 10 consecutive times. Now, our human brains are not equipped, not trained to understand the statistics of that. So you know that's who all the cameras go to. And they say, well, how do you feel about this? And you know what the person will say? You know, I knew I was going to win about halfway through. I had those heads vibes. You know, I woke up this morning and I knew I'd be lucky. Now, of course, they're not interviewing the other people who felt the same way but lost. Okay? They're not interested in the interview because they didn't win the prize. And so the idea that you were chosen among others, it's hubris to suggest that the whole thing was special just for you. And so I'm here to appeal to your sensibility that whatever is true in the universe, the history of our discovery tells us that we are just simply not special. And if you ever come to an idea that says we're special because we're lucky, you pause for a moment and look at the history of those thoughts and how wrong they have been. And then step lightly as you go forward.